Okay, now what we're doing here, circle equation geometry, essentially it's using equations of circles and circle theorems together. So I thought I'd leave a bit of a gap here and do some, these are essentially the ones you're going to be using. So you're going to be using this one. So I was going to draw some circles, but I thought actually it'd be better if I did. So this one, where this is a diameter. Right, now that is always going to be 90 degrees. So that's the first one you're probably going to use. We're not using that one in this question, but just bear in mind that, and read the question carefully on these. All right, the next one is this. So we've got a radius and we've got a tangent. All right, and they meet at 90 degrees. That's the one we are going to be using, that one. Okay, and the other one, actually, which lots of people forget, is if I've got a circle here and I've got a centre there and a chord there, all right, if I'm drawing a radius, the shortest distance, it's going to be a bisector, but the radius is going to meet the chord at 90 degrees. So again, we're not using that one in this case, but that does come up as well. So you are supposed to know those. They're GCSE ones anyway, so you should know them. It's just applying them to this case. Now, let's have a look at this question. It says a circle has the equation x minus 3 all squared, y plus 1 all squared. So that means this equals 100. So that means that the centre is at 3, negative 1. All right, the radius is 10 as well. Rad 10. Okay, so there we go. So it says the point P, which is minus 5 lines on the circumference of the circle, find the equation of the tangent P. So essentially what this is saying is that this is 3, negative 1, and this is minus 5. Now obviously I've not drawn it accurately, but that gives you an idea of what it looks like. So if we can work out the gradient of the radius, okay, well that's C, the centre, and that's P down there. Okay, and then we find the negative reciprocal. It's easy for me to say. Okay, then from there we can find the equation of the line, the equation of the tangent, can't we? So the gradient of CP, centre to point P, is going to be CP is, so it's minus 1, minus 5. Oh, I don't know why I put a comma in there. Absolutely no reason to put a comma in that. There we go, good. Minus 1, minus 5 over, okay, what's that? 3 minus 5. And so I'm going to get minus 3/4 there, which I'm going to have to squash in. So that means that the gradient of the tangent at P is going to be 4/3. Okay, now I'm going to put it into y equals mx plus c. So y, so I know the point on the line is that, so 5 equals 4/3 times negative 5 plus c. Now, when I do all of that, I should end up with c equals, 35 over 3. Okay, now that means that I could do this and just say y equals 4/3 x plus 35 over 3. Or it could ask me to write it in the form, and I'll do it in a different colour actually, ax plus by plus c equals 0. It's quite A-level-y. All right, but if I was to do it in that form, I'd multiply 3 by 3, so I get 3y equals 4x plus 35, which I'd then rearrange to get, 4x minus 3y plus 35 equals 0. Okay, but any of those is absolutely fine. If you're not keen on fractions, that's why they do this particular one. But it's knowing your circle theorems and understanding what the equation of a circle shows you. They are the keys to this.